back to my channel Cat by Nagendra. So in this video, we are going to start about assembly design in SolidWorks. Now just let me enter into here new assembly design. Why? Because we don't want to repeat introduction for assembly design. So as already we know, like two type of assembly designs will be there. Just you can refer our earlier video to get clarity upon different type of assembly designs. Now just I'll go here with new. We are going to start here with assembly design. First, let me explain all that commands. Later, we can go for assembly design. So just I'll say OK here. So first, if we enter into assembly design, directly it will ask to start an assembly design. But here we are not going to start any assembly design. Let me close this. First, we'll go here with commands. Now, first option we are having here, edit component. So edit component means, let's say for example, in this assembly design, we have inserted some parts. That parts we need to edit. So if you want to edit that particular part, again we need to go back to part design and no need to edit. Directly in assembly design itself, we can edit that component by using this edit component option. That I'll show you. Then next option we are having here, insert component. So most of the times we will be using here bottom up approach, like bottom up assembly. So as already we know, bottom up assembly means like first we will create parts, we will save it in one separate folder. Later we will enter into assembly. From here we will call single individual part and we will make assembly design. So to call that existing parts into assembly design, we use here insert component option. Now let me show you how to use that option. So just I'll click on this insert component. Now let's say for example I need to open one part. For example, this part I need to open. Just will select that part and I'll say open. Like this, one part is able to insert into assembly design. So before inserting this part, we are able to change here inclination if you want, like rotation, or else with reference to X you need to switch, or with reference to Y, or with reference to Z. However we want, we are able to make this proper orientation like this. I'll keep it here, just one click here. So like that, this single part is inserted into this particular assembly design by using this insert component option. Now let's say for example, we need to edit this. Just I will select this part. If I select here, you can see edit component option highlighted. So if I select this and if I go for edit component, just we need to save and we need to go for editing. So if I save and if you go for editing, it will save as assembly. Then we are able to edit this particular part. So that is about this edit component and insert component option. Next, we are having here new part and new assembly. So these two options will be used in top-down approach. Like top-down assembly means here in directly assembly we need to create parts and sub-assemblies. In such condition we can use new part and new assembly, these two options for top-down assembly. So while discussing about top-down assembly, we will see these two options. Then next option we will be having here copy with mates. Here mates is nothing but relation between two different parts. So this option also again later I will explain once if I finish this mate option. So I hope you have understood about this. Then next option we are having here mate option, which plays major role in an assembly design. It is very important option here, mate. So mate is nothing but it will give the relation between two mating parts or two different type of parts. Let's say for example, this part is there. Now same part I need one more. So in such cases, no need to go again for insert component and no need to call this part. Just you can hold control, just you can drag that and you can keep it. One more part will be created here. Then if you want to apply relations between these two, we can use here mate option. Just I click on mate. Here different type of mates will be available for us. So mainly we will use here standard mates, then advanced mates will be available, mechanical mates also will be available. First let's see this standard mates. I'll open this standard mates. Here first option we are having here coincident. Coincident is nothing but just it will attach one to each other. Let's say for example, this top face, it should be attached with this top bottom face. Now here made selections. For example, I need relation between this top face to this bottom face. If I say OK, you can see here properly it will come straight to that. By using Ctrl+1, I'll keep it here front view. You can see this is straight to this. So like that we can use coincident mate. So coincident is nothing but it one profile it will attach with one more. Either we can use between face to face or axis to axis or plane to plane also we can use. That is about coincident mate. So again let me show you again one more time. Just I'll go here with coincident mate between this face to this top face only I'll select like this. It is straight to that. Then here again different options we are getting here. Same whatever we are having separately here only we can get. Like instead of using coincident we can make it parallel to each other or perpendicular to each other, or we can log the two components, or we can give distance also. Again I'll show you here. Then here you can see reverse option. This face and this face we don't want straight, we need in opposite direction. There we can use reverse option. So that and this face it will get opposite in direction like this. However we want we can set, and let's say okay. Like that we can apply this coincident mate. Then parallelism will be there. So just we can apply between relation between two components. Now just somewhere here it is there mate. I need parallelism relation between this face and this face. It should get rotated and it should be parallel to this face. So this to this I need parallel with reference to this. You can see it will come parallel to each other. Same here also, if you want reverse we can make it reverse. Like this we can use this parallel relation. Mate. Then perpendicular will be there. Let's say for example this face it should be perpendicular to this face. So just I'll select this. As you can see it will come 90 degrees to that. Like this. We can use perpendicular relation. Then next tangent we can use. Tangent between this curvature to, let me select here tangent between this circle, it should be tangent to this face like this. You can see tangency relation will be there like this. So once if we start with assembly designs, we'll be using all these different type of mates. Then concentric is mainly used for circle to circle. For example, the center point of the circle should be exactly center of this circle. In such cases, we can use concentric relation between this to this, mainly used for circular profiles like this. So this center point and this center point should be straight now. So there we can use concentric relation. Then lock option will be there. Just we can mention whichever the shape we want, then just we can lock the two components there itself by using this lock option. Then distance will be there. Let's say for example we need to give some dimension between this face to this face. Now I need distance between this face to this face. How much dimension we want we are able to give here. For example I need some 25. If I say OK, it will be created with a distance of 25 here. Then similar to that here angle will be there. So if you want different type of angle between this to this, we can give angle mate I want between this face to this face. Like this, how much inclination you want we are able to change. If I give some 60 degrees, it will be with inclination of 60 degrees here. So in such case, in such way we can use this standard mates. So mainly we will concentrate on standard mates. Again later next we can see this advanced mates and mechanical mates. So about these two mates, again separate video I will create on advanced mates and mechanical mates. Then next we can see here component preview window. For example, for this particular component I need to see preview only for that particular component. If I select the part and if I go for component preview, separately we are able to see preview of that particular component. Then later we can use exit preview to come out of the preview. Then next we are having here different type of patterns. Whatever we have seen in part design, same here also we are having here different type of patterns. So this about these patterns, let me explain with one example of assembly design. So already we know like linear component, again circular component pattern, pattern driven, again sketch driven, curve driven, chain component, mirror, all we know already in part design. Same similar to that, here only we are able to create these particular patterns. Then smart fasteners will be available. So whatever we will be having the screws, studs, all it will be available here. But here separate toolbox should be needed here. So we are not able to use this. So by using these smart fasteners, directly we can insert bolts and nuts into this assembly design. Then next we are having move component and rotate component. By using move component, we are able to rotate the, like we are able to move the component from one place to another place. If it is undefined, directly we can hold and we can move. So in some cases, if you want to move with reference to some particular directions, so can use this move component. Here different options will be there. Free drag means however the direction we want we can drag that, or else along assembly XYZ means only we are able to move with reference to X, then Y and Z directions like this. Next, along entity, like with reference to which part we need to open, just we can move that particular component like this. Then by using delta XYZ with reference to X axis how much distance, with the Y axis how much distance, like that we can move again to XYZ position. With coordinate values, we are able to move that particular component by using this move component option like this. Next option we are having rotate. Just we can rotate the component however we want like this. That is about move component and rotate component. Then show hidden components option will be there. Let's say for example this part I will hide, but we don't know how many parts were in hidden mode. So if you want to see that all hidden components at a time, we can go here with show hidden components. So this is the component which is hidden. Just we can select that and make it here exit show hidden. It will be shown automatically. That is about show hidden components. Then assembly features will be there. Usually these options will be found in part design. While creating part design only, we will create all these options like extruded cutter, simple holes, hole wizard, everything. In case in assembly design, if you want to create, we can use this and we can create these features. For example, I need some hole wizard, which type of hole, similar options what we have seen in part design. But here we are able to create directly in assembly design like this. You can see directly for assembly design also we can use here all these options like fillets, chamfers, extruded cuts and everything. Then reference geometries are there like plane, axis, coordinate system, point, everything we seen in part design. So here mainly SolidWorks assembly design means we need to concentrate on this mates only, different type of mates and this different type of patterns. Then next we are having here bill of materials. So bill of material is nothing but we are able to give detailed information about an assembly design in a tabular column. We call it as bill of material with particular assembly design. Let me show you in next video. I'll create one proper assembly design. For that I'll show you this bill of material. Then exploded view also, and exploded view line sketch will be there. These two options also I will explain you with some proper example of assembly design. So this video is only to explain these particular commands. So then instant 3D is nothing but if it is turned off, we can't edit any dimensions here. But if it is turned on, directly we can edit this particular dimensions like this. That is about instant 3D. Then update speed pack. Again, takes screen snapshot will be there, just like a photo it will be taken. Again, large assembly settings and isometric. So only few options will be available for us in this assembly design. Now, next video, let me show you one example with proper assembly design and let me explain you about these patterns, then this bill of material and exploded view. Thanks for watching. Keep supporting.